So this is the best example, Darwin features. And we will discuss also a second example. The second example is the Australian marsupials. Australian marsupials. In case of Australia, there are some ancestor marsupials from which diverse type of organisms evolved. So this already I have drawn here, you see. This is the marsupial radiation. So this is at the center. At the center there is the common ancestor. So this common ancestor, we can call it is the Australian marsupials. Now from this Australian marsupials, you see Tasmanian wolf developed, tiger cat, banded anteater, marsupial rat, kangaroo, wombat, bandicoot, koala, marsupial mole, and sugar glider. That is, from a single ancestor, different types of organisms have developed. And the same area, that is Australia. That means the same geographical area, from a common ancestor, where diverse types of organisms develop depending upon their need, that is known as divergent evolution or adaptive evolution, because they have adapted their structures to do a particular function. This is known as divergent, the adaptive radiation or divergent evolution. So these are the two examples, best examples and important for examination point of view. One is Darwin finches, the second is Australian marsupials, this one. Then come to the next one, the fifth evidence. So the fifth evidence is convergent evolution. The fifth evidence is convergent evolution. Now it is the convergent evolution, development of similar functional structures by unrelated organisms. Development of similar functional structures in unrelated groups of organisms. So here you give importance at 2 points: similar functional, unrelated groups. Now in case of divergent evolution, what we have discussed? We have discussed different functional, but the ancestors are same. But here it is just reverse. Here development of similar functional structures in unrelated species. So you should not get confused, because this is important for examination point of view. So development of similar functional structures in unrelated groups of organisms is known as convergent evolution. Now here we can give again example. Now example number 1, and example 1 is we can give the example of wings of insect, bird and bat. Now see, the insects are invertebrates, while the bird and bat, they are vertebrates. Again, the bird belongs to the class apes, while this belongs to mammalia. So these are belonging to different classes, but they are vertebrates. Insect is invertebrate. Now, if we'll find their wings, the origin and structure of wings in these three organisms, insect, bird and bat, these are different. Different in origin and structure of wings, different. But function is same. But function is same. So what is the function? Function is for flying. That means it is similar function, and they are unrelated groups. You see, unrelated insect, bird, and bat, they are quite unrelated. That means when similar function but conducted by unrelated groups of organisms, that is known as convergent evolution. So this is one example. Now let us give a second example. The second example is again we can take that of Australian marsupials and placental mammals. Now again you see this chart I have written earlier. Now these are known as placental mammals. Placental mammals means when the child is within mother's womb, it will get its food through placenta. So this is highly evolved. But marsupials, they give rise to underdeveloped offsprings. That is not completely developed. That is why they put the offspring in a pouch in their belly for some time till the growth is complete. That means this is a primitive type. But you see, though they are of two different types, the placental mammals are more advanced, they are more primitive, but they perform similar type of function. So see, the placental mammals mole, it is similar in function to that of marsupial mole. Similarly, anteater, and this is numbat, that is also anteater. Then mouse, marsupial mouse, they have same function. Lemur, spotted cuscus. Flying squirrel, flying phalanger. Then the bobcat, this is Tasmanian tiger cat. And wolf, Tasmanian wolf. Though they are completely different, but function is same. So these are again two best examples. One is wings of insect, bird and bat. The other is Australian marsupials and placental mammals. They are coming under convergent evolution. Then the another one we'll discuss is parallel evolution. The sixth one is parallel evolution. Parallel evolution. Now the parallel evolution is closely related to this convergent evolution. That means when the convergent evolution is found in closely related organisms. That means here we have discussed that convergent evolution takes place having similar function but unrelated groups. But instead of unrelated groups, it will be closely related groups. Then it is also known as parallel evolution. So example of a parallel evolution. One example you can give the placental wolf. So one example, placental wolf is found in Asia while a marsupial wolf is found in Australia. Now this placental wolf and marsupial wolf, they are found in two different regions, but they are closely related. So this is one example. Then we can take a second example. The second example is that of the running deer. It has it is two-toed, and that of the horse which has a single toe and two vestigial splint bones. So see, these two are coming under the parallel evolution. That means they are closely related groups and they perform similar function. So here they have a same horse and the deer, they have same function, and they are closely related. So these are the different examples from this biogeographical evidence, and this part is very important, the convergent evolution, divergent evolution, relative radiation, parallel evolution. All these are very, very important for examination point of view. Then let us discuss questions. So one question we can take, the process by which organisms with a different evolutionary history evolve similar functional adaptations in response to common environmental challenge is called first choice convergent evolution, second choice non-random evolution, third choice adaptive radiation, and fourth one is natural selection. And this question was asked in NEET 2013. This is the first year in which NEET was conducted. Before that it was AIPMT. Then the second question, an evolutionary pattern characterized by rapid increase in the number and kinds of closely related species is called So here A choice, convergent evolution, B choice, divergent evolution, C choice, adaptive radiation, and fourth choice, parallel evolution. And this question was asked in Aligarh Muslim University, so that is 2012. So these are the type of questions which are usually asked in examinations, and after going through the video you will be able to answer both the questions. As already I have told you in the very beginning that this biogeographical evidence of evolution is very, very important for examination point of view, because as you have seen, the divergent evolution, convergent evolution, parallel evolution, all these are very, very important. So thank you very much for watching it. God bless you. Have a good day.